Good morning, students. In the last class, we started with Module 3. I gave an introduction to Module 3, the syllabus, what are the topics, what we are going to cover as part of this module. Uh, we started with the sequential circuit. We differentiated between combinational and sequential circuits, and we understood about synchronous and asynchronous sequential circuits. And I also introduced about the basic bistable element. And we started differentiated between latch and a flip-flop on brief, right? And also we studied about SR latch. We studied SR latch. Everyone can see the screen, my PPT.
Yes, sir.
Okay, yeah. I explained about the SR latch, how it works, and the behavior of the SR latch is given by the function table. We understood about what is the next state, the previous state, the present state, right? We understood about the working of an SR latch, and also we studied about S bar R bar latch, the complement, the SR complement latch. Here we use an AND gate. In SR latch we use a thin OR gate. We understood this one, and also I demonstrated the same with the help of simulation. In today's class, what we study is we study about gated SR latch. The gated SR latch is also called as SR latch with enable. It is also called as SR latch with enable. If you see, if you might seen the working of an SR latch or the complement of SR latch, what we understood in the last class, as and when there is change in the inputs of S and R, immediately the output states will be affected there, right? Right. In the sense, what we have is it is asynchronous or direct there. The SR latch, what we studied before, is asynchronous. We call it as a direct. It means the output is uncontrolled. As and when there is change in the input, there is immediate change in the states of the output there, right? But with the help of this gated SR latch, we can have a control signal, right? The control signal, what we have is enable, right? With the help of this control signal, enable signal, what we can have, which is called as an enable gate or clock input, we can make sure that only at a desired whichever time you want the output state to change the states, only at that time you can make sure that with the help of this enable signal and the whatever the input changes you have done, with the help of this enable, the outputs will be reflected there, right? So that you have better control on the output states here. Like whenever you want the changes to be, like we say that a prescribed period of time, right? At particular prescribed period of time you want the output to change, at that time this enable signal what we have is going to be very helpful, right? Understand, that is the difference what we have with a SR latch, what we studied in the previous class, and this gated SR latch, right? If this enable signal is on, then only the whatever the input what you have given here, S and R, that is given to the next stage, and depending on those inputs the output will be reflected here. And if you say what is the truth table for this one, now as I say here, this is acting as what, if this is yes here, since this will be acting as an inverter, this is as an inverter, so that what we have, this is yes bar and this is R bar here, right everyone? So that what we have, this one is S bar and this is R bar, and with the help of this one it is acting as what now, It is acting in an inverter and not gate when the enable signal is on here. And this is similar to the SR latch. The only difference, as I said here, the difference is you can make the output will be reflected only at prescribed period of time, which all depends on the enable signal. If the enable signal is on and you apply the input, so depending on the input, the output will be reflected. Right? This is about the gated SR latch. Just a minute, I'll go to the whiteboard. This is a NAND gate, everyone. This is a NAND gate what you have, and this is your enable signal what you have it. Maybe this could be yes, your yes or right? And if this is 0, if the enable signal is 0, take an example of this, the input what you applied is 0. For AND it will be 0, for NAND it will be 1, right? Now you applied a 1 here. For AND it will be what now? 0. For NAND it will be 1, right? If what I'm trying to say is that if one of the inputs of a NAND gate is 0, the output will always be 1 irrespective of the other input taking the value of 0 or 1 here. This condition we call it as what? A disable condition. We call it as a disable condition, in the sense the inputs, whatever the input you applied, depending on this functionality, the output should have reflected, the output would have changed. But since one of the input is 0, what is happening here? Irrespective of whatever you apply to the other input, whether it is 0 or 1, the output still remains 1 here, right? When that is what we say, if the C signal, which is the control signal what we have, the control signal is 0, we call that state, we call it as a disable. We call that as a disable. So that it means that the whatever input you apply there, that is not carried forward to the next stage here, right? Now we'll see when the control signal is logic 1. If this control signal is equal to 1, what will happen here? Now if I apply 0 here, what will happen now? What will happen here? Since it's 0, 1 for AND it will be 0, for this it will be 1. Now apply the input to be 1. For AND it will be 0, right? And it will be 1. For this it will be 0. So that what we understood here now, output what you can see here, when 0 was applied, when 0 was applied here, when 0 was given here, we got an output as 1, and when the input was 1, we got the output as 0. It is acting as an inverter. The NAND gate is acting as an inverter when the control signal C is equal to logic 1, so that whatever the input you have, right, like depending on the functionality of that gate, that is passed to the next stage, right? So that what we have here, this is nothing but your S bar or R bar here. R bar. Everyone understood this one? So we know it, like I just wanted to explain about the importance of 1 and 0 for the control signal, right? So that what is the function table, we have it here. If it is 0 0, and if the control signal is 1, if the enable is 1, right, then only these inputs will be passed to the next stage. Depending on, since it is an inverter, the whatever input you applied, it will complement it and give to the next stage here. So that what you are, the next stage is nothing but equal to, it is nothing but the previous states what we have. If S is 0, R is 1, and the control is enabled, what we have, the next state is 0, right? Similarly, when S is 1, R is 0, and the control is 1, what we have here, it is the next state is equal to logic 1 irrespective of the previous state. And when both S and R are 1, right, with the enable on, what we have, the next state is equal to 1, which we call it as an undefined state or a forbidden state. And also you can see in the last row what we have, you've written it as X and X, and the control signal is 0 here. It means that if the control signal is 0, if the control signal is 0, what it, irrespective of the input what you apply, maybe it could be any combination 0 0 0 1 1 0 or 1 1, right, whatever combination you apply, if the control signal is 0, the output still remains in the previous state. Whatever the value which is stored in Q, that still remains in the same state. If it is 0 before, it still remains 0. If it was 1 before, it still remains 1, because control signal is 0. So that whatever the input you applied, right, that is not carried forward to the next stage because the control signal is 0 there, right? And this is, you can see at the bottom the two diagram what we have. This is the logical symbol for a gated SR latch here, and we have a control signal C here. Everyone can see the simulator window here. Now if you see this one, what we have, when S is 1, R is 1, right? You can 1 is 1, and here the control signal what we have, this is equal to logic 1, right? And what are the states we have? 1 and 1 here. We know that this is the undefined state what we have, right? Now what again, I'll make this as 0, so that when it is, when R is 0 and S is 1, right, what we have, the Q is equal to 1, right? The Q bar is 0 there, right? When it is 0 0, when it is 0 0, we know that when I make the changes, S as 0 and R as 0, the next state is equal to the previous state. What is the previous state we have? Now you can see here, when it is 1 0, Q is 1, this is 0, right? Now I make the changes. We know that, so that when I apply the changes here, when I apply the inputs, this becomes the previous state. The previous state was Q is 1 here. So that when I make this as 0, the output still remains what? 1 and 0, right? The next state is equal to the previous state. Now R is 1. When R is 1, what we have it? When R is 1, the output, the normal output is equal to 0. So that the normal output Q what we have is equal to 0, and the complement output is 1. When it is 1 here, it is undefined state at the forbidden state. Right? Any confusion if you have it in understanding this one? Right? If you see, this is nothing but it is acting as an S bar R bar latch, what we studied, right? The only difference what we have is we have an enable signal, so that depending on the enable signal, you make sure that the outputs are reflected depending on the control signal. If the control signal is on, or if it is enabled, right, depending on the input, the output will be reflected. If the control signal is 0, the whatever input you apply, whatever input changes you do, the output still remains in the previous state. There is no change in the output state there, right? This is about the gated SR latch. Any confusion here? We'll go to the next topic. Next, what we have is gated D latch. D here we call it as a data latch, right? Why it is called as a data latch? In the sense, the whatever input you give, right? If you give logic 0, the output will be logic 0. If the input is logic 1, the output will also be logic 1, so that whatever the data you give to the input, you get same as an output here, right? That's the reason it's called as data latch. And we have a control signal C here. So that what is the function table for this gated D latch? 0 1. If the control signal has to be enabled, right? Enable is given by 1 1. Disable is 0. If it is 1, what is happening there? What is happening there? The next state is equal to 0. If D is 1, the next state is equal to logic 1. It is a little busy. We'll go to this latch, gated latch here, D latch, right? What we have is this enable signal, what we have it, right? And this is the data signal D, right? Now what we have, the enable signal is 1, D is 0, the output what we have is 0. Now I'll make this as logic 1. When D is 1, the output is also equal to 1 here, right? When it is D is 0, when D is 0, the output is also equal to 0 there. So it means that whatever input you give, you get same as an output. This is called as a data latch, right? And the enable signal should be on. If it is 0, what will happen here? If you see what was the state here, we had 0 and 1. I make any changes here, there is no change in the output. The next state is equal to the previous state. Whatever the state, the output was storing that value, it still remains in the same state here. Only when the enable signal is on and you apply the input, depending on the input, the output will be reflected there, right? If the input is 1, the output is 1. Similarly, the input is 0, the output is 0. This is about the gated D latch. Any confusion here, guys? Right? Any doubts? Anyone?